Okay, this video is for naming molecules with two functional groups, how to work out which one is the most important. Remember, we put the main name, the most important name, at the end. So when we do chapter 11, we'll try and do this to look at how alkanes over here, alkanes are off the screen, how they can be turned eventually into carboxylic acids, and how different molecules can be turned if you have the right chemicals into another molecule. So we'll do this poster in for chapter 11, but I thought we could also use this poster to work out what the most important molecule is when you're naming it. So the numbers here, 1, 2, carboxylic acids are more important than alcohols. Ignore aldehydes. We don't need to do naming for aldehydes. So carboxylic acids, alcohols, then go up here, amines, alkenes, alkynes. Okay, so that's the order of importance when you're naming them. Carboxylic acids, alcohols, amines, alkenes, and alkynes. So I've got this up here. Carboxylic acids are more important than alcohols, more important than amines, alkenes, alkynes. So if we're naming the main name based on carboxylic acid and we have an alcohol, then we need to use another word apart from ol on the end to name it. So we call this group, it's a hydroxyl group, we call the name when we're naming it hydroxy. And this amine group, instead of calling the main name amine, if you've got an alcohol or a carboxylic acid and an amine group, then you have to, in your name, use the word amino. So hydroxy and amino go at the front. Just like methyl, ethyl, chloro, bromo, all of those, they're prefixes to the main name. Alkenes and alkynes, even though they're of less importance, they actually change the main name. So if you have an alkene or an alkyne, and any of these, then you add that in the main name. That's why I've got the little, whatever those things are called, on either side, because you have to put them with the number in the main name. Right, so if we do this, this is the example in your book. We do exactly like we always do with naming, find the longest chain. So circle it when you're finding the longest chain. So we've got 4 carbons. So somewhere in the main name is going to start with bute. So identify the functional groups present. So you've got a hydroxyl group and an amine group. Determine which functional group has the higher priority and determine the prefixes and suffixes to use. Okay, so hydroxyl groups, alcohols, are more important than amine groups. So we're going to call this an alcohol. Which means that the main name, it's going to be bute, and the hydroxyl group is on the second carbon, 1, 2. You need to number it so that you get the smallest number. So it's bute, butane, because they're all single, it's an alkane, all single bonds, butane 2-ol. So number it with the alcohol group giving the lowest number. Use the functional group to construct the name. So it's on the 4th carbon. On the 4th carbon, we have the amine group. So it's 4 amino, using amino, butane 2-ol. So have a go at naming this one. I'll pause it. Alright, so same idea, find the longest chain. So we've got 1, 2, 3, 4. This is not a proper structural diagram because we're not showing the bonds here. But we've got a carboxyl group, so it's a carboxylic acid, and an amine group. Carboxylic acids are of more importance than amine, so we're going to call this, it's got 4, so it's butanoic acid. And remember, this carbon is always number 1, so 2 amino butanoic acid. Okay, this one, find the longest chain. Longest chain, 1, 2, 3, 4, 5, 6. 6 is hex, so and they're all single bonds, so it's hexane. So we've got an amine group and a chloro group. Amine is of more importance, and it's on the first carbon. So it's hexane, 1 amine, and on the 1, 2, 3, 4, 5, 6, 6 chloro, hexane, 1 amine. You've got an alkene and an amine. Amines are of more importance than alkene, so that's going to be the main name, but we still put the ene in the main name. So it's bute. We need the numbers as small as we can make it. Bute 1 ene, en, 1 amine. Okay, so the main name is amine, and you've got a bute. You can't put butane, so be really careful. Don't put butane because it's an alkene. So cut off the an. It's bute, 1 ene, 1 amine. Okay, this is the skeletal diagram. You need to get used to these because they might give you something like this where they haven't drawn the carbon that's here, the carbon that's there. So every bend has a carbon on it. When you get to the end here, there's a carbon here, but this goes up to the oxygen. If this ended and there was nothing there, then there would be a carbon on the end. Okay, so there's 1, 2, 3, 4, 5, 6 carbons. Okay, you've got an alkene group and an alcohol group, a hydroxyl group. So when we look at the naming, we've got carboxylic acids. Remember that poster? Carboxylic acids, alcohols. Alcohols are of more importance than the alkenes, which were down here on the poster. So this is going to be, I've forgotten how many there are. 1, 2, 3, 4, 5, 6. 6, it's going to be hexane, 1 ol, but this also has to be in the main name. So it'll be, because it's a double bond, it won't be hexane, it'll be hex, 1, 2, 3, hex 3 ene, 1 ol. So remember, anytime you see a double bond, you need to start doing if it's a cis or trans. So if we look at the hydrogens, if it's got hydrogen, that makes it easier. The hydrogens are on opposite sides, so it's a trans. Okay, so this has also got a double bond and an alcohol group. We've got 1, 2, 3, 4, 5, 6 carbons, so it's hex. It's got a double bond, so it's not hexane, it's going to be hexene. Remember with the naming, carboxylic acids, alcohol, so the alcohol is of the most important. 1, 2, 3, so it's hex. This is the fourth one, hex 4 ene, 3 ol. Okay, and you should have circled the longest chain, and you realise that this is a methyl group hanging off the second second carbon. So it's 2-methyl hexane 4 ene 3 ol. Okay, so the ol is on the end because it's of most importance. So is it cis or trans? So there would be a hydrogen hanging down here and a hydrogen hanging up there. Okay, so it would be trans. All right, this one, if we look here, there's a carbon here, carbon here, and a carbon up there. So 1, 2, 3, 4. So it's bute again. We've got a carboxylic acid and an alcohol group, hydroxyl. So this carboxylic acid's of more importance. So it's a butanoic acid. And hanging off, remember that's always number 1. 1, 2, 3. So we've got 2 bromo, 3 hydroxyl. And we put the bromo first because alphabetically. So the B is before the H, butanoic acid. And the hydroxyl group with an L is called hydroxy. Okay, this one, got 1, 2, 3, 4. So the carboxylic acid, carboxyl group, is of more importance. So it's butanoic acid. But on the 1, 2, we've got an alkene. So it's but-2-ene-oic acid, okay, which sounds very strange. And then on the second one, we also have this methyl group. So it's 2-methyl-but-2-ene-oic acid. Okay, so remember, don't have the "an" here. It's an alkene. So this looks really weird. Ene-oic acid. Is it cis or trans? So this is pointing up, and there would be a hydrogen here pointing down, hydrogen pointing up. No, not a hydrogen pointing up, this entire group. So we've got a methyl group down here, and then this entire group pointing up. So you want to know, this has got a hydrogen. When there's not two hydrogens, what you need to do is look for the longest chain. So this is the longest chain on this side, and it's pointing up. And this is the longest chain on this side, and it's pointing up. So they're both going in the same direction. So they would be cis. Cis like sisters, remember, both going together. All right, have a go at putting molecules together. How many different molecules could you make if you had 5 carbons, 7 hydrogens, 2 oxygens, and a bromine? So just play around with them. Try and put some carbons together. Count how many hydrogens you've got, and check. Have you got more hydrogens than that? So have a go. Pause the video, and then I'll show you what's happening. Okay, so hopefully you've had a go and you realise that if you put 5 carbons together, you're going to have too many hydrogens. So you need a double bond. Okay, you need a double bond, so that if you don't have a double bond, you would have found that you had 9 hydrogens. So there needs to be a double bond. I've chosen to make a carboxylic acid with my 2 oxygens, but I could have made an ester. I could have put 2 alcohols on either end. Okay, so, and I've chosen to put my double bond here and my bromine there. But you could put the double bond here, and you could put the bromine on the end, so you could move them round. So there's lots of different ways of making that. So if we named that, because it's got a double bond, it's another ene-oic acid, and it's got 5 carbons. So, sorry, this mouse just keeps disappearing. 1, 2, 3, 4, 5 carbons. And on the one, this is always number 1. On the second one, you've got a bromo group. So it's 2 bromo pent 2-ene-oic acid. So 2 bromo pent 3-ene. 3-ene would be if you moved the double bond across my mouse to here rather than to there. This one would be a 4-ene-oic acid. Okay, so you can do the same again. You can just move the bromine around. I don't know why I've written 12. Oh, so there's 12 straight chain carboxylic acids with a double bond. Then you can branch them. So you could take this off the end. So instead of being here, you could put it here, and you can have a branched form. And you could also do this with esters. So there's lots and lots of molecules. So the formula doesn't tell you which molecule, and we need to get used to the idea once we start doing our chapters of working out what molecule we've got, looking at infrared and NMR and all these different techniques. Lots and lots of molecules can be made with the same formula. So what is the functional group on this molecule? So sometimes you have to circle functional groups. So this functional group is an amine. This is methamphetamine. A student asked me what that looked like at one point. Lots of molecules that are effective in your body have a ring structure, a benzene ring. Functional groups here. So we've got a hydroxyl group over here. And later on, when we look at proteins, we've got what used to be a carboxylic acid group here and what used to be an amine group. And when they get together, we make it an amide group. That's Panadol.